Hi, today is our first lecture on graph theory. So, graph theory, as the name suggests, is the study of graphs. So, what is a graph? Okay, so in layman terms, graph is nothing but it's basically a visual aid to visualize relationships between various components. Okay, so basically, that's the basic idea of a graph. That means there are some objects are there, and there are some kind of relationship between these objects, and when you have to analyze this relationship by use of a visual aid, which is basically a graph theory. So it's a very layman definition of this thing. I'll elaborate further. Okay, for example, in a particular city, there is a salesman. He has to visit some maybe some areas in the city like this. So we know the map of the city, and we know the distance between these areas, and he has to visit all these areas in the shortest time possible, or maybe he has to move from one point, maybe this point A to maybe this point C in the shortest possible way. Okay, so there are many ways for him to move from A to C. So one way is he can remember this map, whole map, and you can look at the map, but it will be confusing because there will be so many areas would be marked in it. So instead of remembering the whole area, what he will do is that he will just look at the points where he will look at the points or places where he has to go. So these places are like this. There are A is there, B is there, maybe E is there, okay, D is there, F is there, G is there, H is there, I is there. Okay, so he'll just label all these points, and then he'll write down the distance between these points and everything like that, and then he'll analyze only this point. There is no need to imagine or visualize the entire map. Instead of that, he'll be just looking at these points and then the connection between these points only for better understanding. Okay, for example, this instead of remembering this entire map, now he can look at this small representation of these areas like this A, B, E, C. So basically he will only look at this representative image. So looking into this image, he will get an idea through which path he can easily come to see in the shortest possible way. So basically graph is a visual aid to what is a graph is basically a visual aid to simplify certain problems and to find solutions. Instead of remembering the entire map of the region, you can easily remember in layman terms the basic what do you say, the paths between A, B, F and H, G and H. So you just only need to remember the connections between the different nodes. Okay, so this is the graph here, and so basically when you are talking mathematically, graph contains of two objects. So one object is basically it contains of two sets of things are there. One is the vertex set and another is the edge set. Okay, so here you can see that A is the A, B, E and maybe Z is the are the vertices of the graph. They are said to be the vertex, or in plural vertices of the graph, and this thing, this line is called an edge. So usually in different textbooks they usually use different notation. Sometimes they will write this as edge AB, or we will give a new label to this edge AB. Maybe you can call this as E1, I will call this as E2, I will call this as E3, or I will just call this as A comma B in brackets. So basically all these denotes an edge here. So basically graph, mathematical terms, graph is basically the collection of two objects. One is the vertex set and next is the edge set. Okay, so so basically this graph will help you to explore the connections or paths between different vertices using edges. Okay, so that is what I meant here. So it's a network that helps to define and visualize the relationship between various components. So basically you can see here that we can know the relationship between 0 and 6, there is a relationship there, and 6 and 7 there is a relationship there, 0 and 8 there is a direct relationship there, 0 and 1 there is an indirect relation through the way of 8. So if you want to find the shortest possible way to go from 0 to 5, you can explore this graph. Okay, so this contains two things. One is vertices, other is edges. Okay, now why are we studying graph? What are the applications? The applications are immense, are there, just as I told you. Now I have to show you this traveling salesman problem. That's an application of graph theory to find the shortest path. Okay, and there are also some other what you say, not so obvious relations also there. For example, in mapping application, which you have already discussed is there. Then in social networks, okay, in social networks we have to find when you're trying to study the connection between various peoples, and in the there is a famous lemma called the that's called the, I think, 6 handshake theorem. Okay, you can look up in the internet for that. Okay, it says that any person in this world, any person, maybe me, you, or anything, can actually connect to any other person in any part of this world using just maximum of 6 handshakes. Okay, so any person in this world can connect to any other person using a maximum of 6 handshakes. That's just what you say. We will say it allegorically, but it's very simple. For example, suppose I am here, I need to connect to maybe the President of United States. Okay, so what will I do? So I'll go to a person I hope who knows, who is more has a more probability of who's a more probability of getting connected to the President of the United States. So what I will do is I'll go to the principal of our college. Okay, okay. Then I'll shake hands with him. Now this principal is basically a well-known person, and he may be knowing some other well-known individual in maybe United States when he are going to conference there. So he can handshakes with him. Okay, now that person again maybe a good researcher or maybe a well-known scholar, and maybe he could actually shake he may have shaked hand with actually the maybe Secretary of State in the United States. Okay, so now we have 1, 2, 3 and 4 handshakes, and this Secretary of State in the United States would have shaken hands with the President of India, President of United States. So in 5 handshakes we have done the process. So this is basically what you say, it's for entertainment purpose only. So this is actually exploration of a social network. Okay, so in order to study social networks in in social media groups, or if you want to explore the connection between pages and all, we can use it using graph theory. Okay, now similarly this is an entirely different thing. Even for solving Sudoku and all, you know what is a Sudoku? Okay, so for solving Sudoku also you can use graph theory using an algorithm there. So we'll look at the later chapter of this module, later of this section, this course. Okay, so for solving Sudoku also you can use the concepts of graph theory, particularly called coloring. Okay, so using that you can easily solve graph theory when you use a computer. Okay, so that's there. And now we will go into the definition of graph theory, which is already told you. Graph is basically a two-turn set. It contains of vertexes and edges. Okay, so this is called vertex and this is called edge set is there. And now each edge represents the connection between the vertices. Okay, so I am giving you an assignment. You have to write down all the terminology related to graph. So you have to define what is a graph, you have to look at what is a vertex, you have to define what is an edge, everything like that. Okay, so I have already given you the textbook. Look at the textbook and then try to write down the definitions, because in the examination they can ask you define a graph with an example. Okay, now before that there are one or thing is there. So what is called order of a graph. Order of, these two concepts are there: order of a graph and also a size of a graph. Okay, order and size of a graph, very simple things only. Order means basically the number of vertices in the graph, that's it. So what's the order of the graph here? It is basically 5. Okay, now size of a graph is basically the number of edges. So how many edges are there? 1, 2, 3, 4, 5, 6. So 6. So 6 is the size of this graph. So define order of a graph, define size of a graph. Order is basically the number of vertices and size is basically the number of edges. Okay, now we'll look at some different types of graphs. Okay, so one is most simple thing is actually simple graph. Okay, in simple graph the main point is that it will not have loops or multiple edges. It will not have loops or multiple edges. You should define what is this loops. You should also find the definition of multiple edges. Okay, so loop, it is very simple. So if I draw an edge from 0 which ends at 0. Okay, so basically there may be some paths which starts as a point and ends at that point. So basically if I start draw an edge, so usually we draw edges between different vertices, but there is no restriction like that. We can always draw edges between the same vertices itself. So basically I am drawing an edge called E which starts from 0 and then ends at 0. So this is called a loop. Okay, okay. So in data centers and all, if you are modeling data centers, you have communication links and all. So self-diagnosed, so centers having that self-diagnostic loops are called, so that's a model of this thing. Okay, so loops is basically an edge which starts from a vertex and ends in that vertex. Okay, I hope you understand what's a loop. Now there is another definition called the multiple edge. Multiple edge is basically, as the name shows, now you have an edge between 0 to 2. I can also draw another edge between 0 to 2. So there can be many paths between two towns, right? So basically this is called a multiple edge. Okay, so a simple graph is a graph which does not have loops or multiple edges. Okay, so you can see the example of simple graph here. So it does not have loops and multiple edges, but now this is an example of not a simple graph, that is it has multiple edges and also loops. So a graph which is not a simple graph is called a multi-graph. So in some textbooks they call them it as multi-graph. Okay, so multi-graph. Okay, so I hope it is clear. Okay, now there is another class of graph called digraph or directed graph. So it is basically called directed graph or digraph. Okay, directed graph or digraph. So what do you mean by directed graph or digraph? So in this case the edges will have directions attached. For example, you can see this here. There is an edge from A to B. No, there is no edge from B to A. So when you model problems involving that one-way routes, okay, so we can only go through this route. So in those problems, you can use this directed graphs. So these are called digraphs, in which there is a fixed direction is given to each edge. So we will study the more about digraphs in the end of this course. We will not be focusing on directed graphs now. Now basically our focus will only be on simple graphs. Then we will carry our theory to maybe multigraphs and digraphs later. Okay. So I hope it is clear what's a simple. So try to define what's a simple graph, what's a multigraph, what's a loop, and also a multiple edges, and also directed graph. You can write in your own, and there's no need to by heart anything. In graph theory, every definition, every proof you can write in your own words. If the concept is correct, then you will get full marks. Okay. Now I can also tell so one important thing I have to tell you is always label a graph. Okay, so always label a graph so that examiner will understand what which points you are referring. So labeling a graph means I'll just call these vertices as maybe A, B, C, D, or I can call this as V1, V2, V3, V4. Also label the edges if possible. I'll call this as E1, E2, E3, E4, E5, so E6. So whenever you get a graph, try to label the graph for a better understanding of the graph. So you have to practice it from now on. So whenever you give an example of a graph, always try to label the graph. Okay. Okay. Now there are also other concepts called weighted graphs. So in weighted graphs, basically in these weighted graphs, they will give the weights to edges. Okay. This problems usually comes in shortest path problems. Okay. So basically, if you are modeling the distance between some towns, this weight means maybe I'll write this as 10 will be here it will be 5 will be there, here will be 7 maybe, here it is 6, 5, 4. Okay, so basically this numbers may show actually the distance between these points. So these type of graphs are called weighted graphs. We will study more on weighted graphs in the third module when we will discuss, we will take up specific algorithms to discuss shortest path problems. Okay, so I hope it is clear. Okay, now let us look at some more terminology. I hope you understand what do you mean by vertex set. Okay, this collection of all vertices. What is the vertex set of this graph? It is actually, I can write it here, A, B, C, D, E, F, G. So these are called vertex set of graph. Okay, now you can see this graph is, this vertex G is not connected to any other vertices. So this vertex is also called an isolated vertex. So isolated vertex is a vertex which is not connected to any other vertices. I will come to that later. So I'm just telling you what's an isolated vertex. Okay. Now I hope you understand what's an edge set. Here edge is not labeled, so I can write the edge set as simply AB is there, BC is there, CD is there, BE is there, EF is there, AF is there. Okay, so this is the edge set. Now already we have discussed order and size of a graph. Order is actually the number of vertices of the graph, size is actually the number of edges of the graph. Okay, now what do we mean by adjacent vertices? Adjacent vertices are those vertices which are connected by an edge. It's very simple. For example, A and B are adjacent vertices. Okay, A and F are adjacent vertices, but A and D are not adjacent vertices. Is it clear? Okay, so you can see that A and B are adjacent vertices. Okay, B and C are adjacent vertices. C and D are adjacent vertices, but B and D are not adjacent vertices. Okay. Now suppose let us look at another concept called neighborhood of A or neighbors of A. So what is the neighborhood of A? Neighborhood of A or N of A. Okay. So basically set of all adjacent vertices of A is called the neighbors of A. So okay, can tell me what are the neighbors of A in this figure? It is actually B is there, F is there. So here neighboring set of A is actually B comma F. Okay, similarly the neighbors of B would be A will be there, C will be there, E will be there, F will be there. Is that clear? Okay. Now suppose I am labeling this edge as E1, E2. There is one more terminology which I would like to emphasize. We will say that this edge E1 is incident on A and B. So it is incident on A and it is incident on B. Or we will say that A and B are the endpoints of E1. So very simple terminology. Okay. So we will say that this edge is incident on A means that edge is actually coming to that set, that vertex A. Okay. So so what do you mean by an edge E is incident on a vertex B? Means that actually this V will be an endpoint of that edge. Okay, so I hope you understand this thing, edge incident vertex. Now next one important thing is degree of a vertex. So the number of edges which are incident on a vertex is called its degree. It's very important concept, degree of a vertex. So number of edges which are incident on a vertex is called the degree. For example, the degree of A here is 2 because there are 2 edges coming out. Okay, similarly, can you tell me degree of B? The degree of B would be 1, 2, 3, 4. It is actually 4. The degree of F would be 1, 2, 3, 4. Again, it is 4. Degree of E would be 1, 2, 3. Again, 3. Degree of C would be 1, 2, 3, 4. So you can see this degree, and degree of D would be similarly 1. Okay, now I'll tell you the concept of a degree sequence. Okay, so what's a degree sequence is actually you will arrange this degrees in degree sequence of a graph. Okay, so you will arrange this degrees in ascending order. That's called degree. So in this graph, the degree sequence would be, what is the degree sequence here? So the smallest one is 1 is there. Okay, then 2 is there, then you have 3 is there, then 4, 4. Okay, 3, 4, 4, 4. So this is the degree sequence of that graph. Oh, I hope you understand. Okay, so there is no, the order is actually I have to write in the degree sequence in ascending order. Okay, now degree of a graph. Next is a degree of a graph. Degree of a graph is actually the sum of all the degrees of the vertices. So degree of a graph is actually nothing but sum of the degrees of all vertices. So what's the degree of this graph? It will be 1 plus 2 plus 3 plus 4 plus 4 plus 4, which is 6 plus 4, 10, 18, 18. So 18 is the degree of the graph. Okay. Okay, so I hope you understand what do you mean by degree of a graph, degree sequence. Okay, and one more thing, in case of loops, suppose this graph, we are not discussing multiple graphs now, but still if it has a loop is there, always you have to give a contribution of 2 in case of loops, because it has the same vertex is acting as both the starting and ending vertex. So when the case of loops, we will give a contribution of 2 to loops here. So if there is a loop at A, we will say that the degree of A is actually 1, 2 plus the loop, it is actually 4. So whenever there is a loop, you have to give a contribution of 2 to the degree of that vertex. Okay, and there are also concept of in degree and out degree in the case of directed graphs. We'll study about it later. Okay, so in degree means actually by name itself it is important. It is very simple. That means if you have a directed graph, okay, so if you are taking this vertex x, only one edge is coming to A, so it is a in degree is 1, out degree is also only one edge is going out, it is called out degree. Okay, so this is the basic idea of graph. Okay, now so we'll stop here. Now look at basic results in the next session. Okay.